Hello, Pedro here. In this quick flow, I'm going to go back into the setup and finish it off by doing the caps. So it's often the case that we actually need the geometry to be closed. First off, though, I'm going to improve maybe the extrusions. You'll notice that, for example, in letters like the O, I have these internal bridge edges being extruded as well. And it's going to make that we have here these bridge polygons. And to be honest, I don't want to have them in there. If I try to, for example, select the outer extrusion of the O by doing a double click, you'll notice that it's going to select everything. And even the UVs, you can see, this is just garbage. I don't need them. They won't be seen. So let me clean that up first. So I'm just going to put these down and I'm going to create some space to put other nodes in here. So these edges, they are needed to define the holes and polygons. So in this case, this O can only exist because of that bridging edge. But for the extrusions, I really don't need them. I just want the outer edges. So I'm going to select those with group create, and we're going to disable the base group. And first off, actually, I'm going to put this set to edges, disable the base group, and put here include edges, unshared edges. And now if I enter, you can see that all the edges are selected, but this bridge edge. Let me change this to a word that has more of those, like node. And you can see that I have in the O, in here, in the D, and in the E. So all of those are not selected. So now I'm going to do a dissolve. And I'm going to select the group that I've just created. And I'm going to take this out, put this in, and select here, create these joint polygons. You notice that at the moment, I just have those bridge edges actually coming out. And so I'm going to put here delete non-selected. Now the holes on those polygons are actually filled polygons. So instead of a single polygon, I have two of them. So if I connect this in here, let me put this here. If I connect this into this, you notice that the profiles that I get, they don't get those little bridge edges. So when I extrude this, I won't have that internal geometry being generated. None of these have those anymore. So for example, I can come here and select the outer extrusion of the O or the internal extrusion of the O, for example. So that's nice. Okay, so now to the caps. The caps, I'm going to use an operation similar to this. I'm just going to use another sweep so that the alignment matches. And so I'm going to use the same backbone. But instead of using the open profiles, the polygon curve profiles, I'm going to use the initial polygons. I'm going to use these ones. And so I'm going to connect this in here. And so this will give me a lot of caps, not just the polygons that I want, but all around. So the idea is, of course, to have only these polygons that are on the ends of the polygon curve. So I don't want these, but I want these. So I have to sort of identify these and delete them. So one easy way to do that is come here to the path. And if I do an attribute, let's say f at and count, and I'm going to say that I want this to be equal to neighbor count for input 0 and at ptnum. So at using the point in which this is being ran. So if I apply, you see that now I have, for example, let me turn on here this selection mode and go into points and bring on the attribute and count. So now you can see that I have points that have the value of 1, which are the ones that are at the tip. These are the ones that I want. And I have also points with a value of 2. These are the ones that I want to delete. So cool, that attribute goes on with the sweep. So I can come in here and just delete. Let me put here delete swap. And instead of doing with a pattern, I want to delete by expression. And so I'm going to put here that at and count is equal to 2. So by doing that, you'll notice that now I only get the polygons that are on the tips. So if I, let's say, put these in the background, you can see that I got the ones that I want. Great. So I just need to do the UVs for these. And so let me put flatten, UV flatten. And I got the UVs. And so I'm going to merge everything. And I'm going to, let's say, put this in here, and now I have everything with UVs, the extrusions, and also the caps. And we can check, if I uncheck this in here, you can see that everything is at the same proportion, which is nice. Now, a plot twist is, well, usually modelers care about where polygons are facing. The default option for the viewport is to give us the back faces. But if I remove the back faces, you'll notice that while the polygons, the caps for the end of the curve are all right, The caps for the start of the curve are not. So the polygons are there. It's just that since I removed the back face, now I can't see them. They're facing inside. And so I want to fix that. And to fix that, I just need to select the polygons of the start of the curve and reverse them. To select them, I'm going to use a group by range. So for each path, I have a word at the beginning and a word at the end. So in this case, it's 4 primitives. And so I know I want to select 4 out of 8. So that's what I'm going to do with the group range, group by range. Let's see, there we go. And if I put this in here and I come here and I put select 4 of 8 and then put this on a reverse SOP. Let's see, here I'm going to select the group 1. And as I connect, let me put this here. So now I'm going to remove the back faces again. And as I connect this in here, you notice that everything is fixed. So I keep the end caps facing outside, but the start caps are now fixed facing outside as well. Now to make this, adaptable to whatever input I put in here. So if I change this to node flow, you'll notice that now everything is fixed, right? Because the amount of primitives in here, in this case 8, is not driving the group by range. So I'm going to have these two connected. And so what I'm going to do is I'm going to create a spare input and I'm going to drag this operator in here. And so in this case, I had 4 by 8, but actually what I want is the number of primitives that is in this operation. And in this other input, I want double of that. So I'm going to do n prims. And for the input -1, which is my spare input. And for this one, I want to put here n prims -1 times 2. And now with this, you can see that everything is fixed. So regardless of whatever I put in here, let me put here the word done, which is 5 primitives, or actually 6 because of this. You can see that it still works. Great. One last thing is that not every mesh operator that we use to create the initial profile will have the same alignment. So for example, you notice that the font is facing the positive Z. But for example, a circle, well, apparently there's no circle, but if we look back, okay, the circle is facing the negative Z. What this will do is that if I put this in here and I check the end result, is that these, the polygons are now facing inside. And there's a quick way to fix this. I just need to put a reverse and, that will do. But maybe we don't want to micromanage this. We want to have an automatic way to assess if the polygon is facing the positive Z or the negative Z and flip it if needed. So what I'm going to do is here at the start, I'm going to put a wrangle in here. And it's going to run on the point. As long as the polygons are sort of, facing the z-axis, I think it will be fine. But I'm going to do an attribute called flip, which is going to be f@flip equal to the dot product of the normal with a static vector value, which is 0, 0, 1, and close parentheses. And now I have this attribute here called flip. Now with flip, what we want to do is we want to assess here at the end if it's negative, it needs flipping. If it's positive, it's okay. So I'm going to put here a wrangle, attribute wrangle, and I'm going to run this one on the primitives. And so what I want to check is that, let me say I want to create a group. So I at group underscore reverse equals to point. So I want to pull that attribute called flip into the primitives. And so I'm going to use the point function. And so I want this to use the input 0. The attribute is called flip. And I want to access it through pgnum. So this is just basically the first point ID of the primitive. And so I want to create for this group, the condition that I want to do is that if it's negative, so if it's less than 0. Okay, so now if I connect this in here and I come here and I use the group called reverse, it should work, but it's not working. Let me see what's going on in here. Oh yeah, it's probably working, but the normals are messed up because before I called the normals here in this one, I wasn't using the normal attribute, but after I did that, now the attribute is there, so it's being used. So I just need to calculate the normals at the end as well. And so everything is fine now. So you'll notice that now regardless of if I put the circle or if I put the font, the polygons, the end polygons, are facing outside when I have remove back faces activated. So no need to micromanage if the polygon is facing what I need. I can have that fixed automatically. So this concludes the challenge that I've put on to people. Let me know what you think of this solution. Cheers.